All right. We're doing question number, it says 54. This is actually question 55. Sorry about that. Hopefully it will be saved correctly in the files here. This is question 55. And question 55 reads this. What is the maximum area of a right triangle with hypotenuse 10? So we have a right triangle here we can take a look at. We'll call this a right angle. We know the hypotenuse is 10. And as you look at this right triangle, your intuition might be, why don't you just break it up and make the two legs the same size? And we'll see if that's true or not. Let's call our leg going horizontally X. We'll call the leg going vertically Y. And we'll get, now we zoom in here, the maximum area of a triangle. So our area formula is area is 1/2 the base times the height. All right, we have our two variables in here. You know we can't do this problem with two variables. We look back at our triangle for a secondary equation, and that right angle kind of makes things stick out. You immediately think Pythagorean theorem. So I've got x squared plus y squared equals 10 squared. Solve this. You can kind of look over here at your right equation, your main equation. X and y are both to the first power, so it doesn't really matter which one you solve for. Let's solve for y. So I've got 100 minus x squared, and I'll take the square root, and since these are measures of distance, I'll take the positive square root, and I get 100 minus x squared. And we know we're in for a bit of a messy derivative on this problem, but I suppose that's only fair. It was kind of an easy setup, so now we're getting into a little bit of work. So what's our area? It's 1/2 x, and then it's the square root of 100 minus x squared. All right, to find a max or min, we'll take the derivative, we'll find the critical points. So I'll take this derivative, and I notice here I have a product. Here's a variable, so like I say, we're getting into a little bit of a mess, but let's go for it. We have 1 d2. I'll bring down the half power. I'll make it 1 less, times the derivative of the inside. So that's 1 d2. And then we have 2 d1. And the root of 1/2 x is 1/2. All right, let's simplify this a little bit. We will factor out our biggest negative power, which is this 100 minus x squared to the negative 1/2. And when we factor that out, give myself a little more space. When we factor that out, we get a prime equals. We'll take out that 100 minus x squared to the negative 1/2. Let's see what's left. Well, my first term, I've got a half x, I've got a half, and I've got a negative 2x. So one of the 2's cancels out. Looks like there's a negative. Looks like there's an x squared. And it looks like there's a 2 left. All right, my second term. Well, I factored out a negative 1/2, but I had a positive 1/2 in here. And the thing you remember about factoring out, it's like dividing. When you divide, you subtract the exponents. I began with a half power. If I take off, because I'm dividing, I subtract the exponents. If I take off the negative half power, I end up with a first power. So I've got here plus 100 minus x squared to the first power. And I still have this other 2. Combine like terms inside my bracket here. So I've got a prime 100 minus x squared to the negative 1/2 power. And combining the like terms, 100 over 2 is 50. And I've got minus x squared over 2 and minus x squared over 2. So minus x squared. Let's write this a little bit nicer. So a prime equals 50 minus x squared all over the square root of 100 minus x squared. Okay, I'm looking for the critical points. So where does this derivative equal 0? And where is this derivative undefined? Well, looking at the bottom of the fraction, I can tell this is undefined when x equals 10. My derivative would be undefined. But in terms of a right triangle, there's no way one of my legs could be 10 because that's the hypotenuse. So I could have set that up at the beginning. My domain x or y both have to be less than 10, and they certainly have to be positive numbers. You can't have a 0 for a side, so somewhere between 0 and 10. So I realize in the bottom of the fraction, for my derivative, that it is 0 when x equals 10, but I also realize that's not in the domain of this problem. So I'm worried about the top equaling 0, which occurs when x squared equals 50, or when x is the square root of 50, otherwise known as 5 square root of 2. All right, is that a max or a min? Well, we could take the second derivative test, although in this problem, the first derivative is a little bit of a mess. So I think I'll stick right here with a chart. Not a real big chart. So I've got the square root of 50 was my critical point. I'll go less than square root of 50. And I'll go bigger than the square root of 50. And let's see what's going on here. So less than square root of 50, how about something like 5 is less than square root of 50? I'll sub a 5 in here. 5 squared is 25. 50 minus 25. I have a 25 on the top. And the bottom, I'm taking the square root, which is positive. I have a positive over a positive, which is positive. Okay, so my function, my derivative is positive, so my area function is increasing. Now, let's go from square root of 50 to 10. How about something like, doesn't matter, 9. So for x, I'll put in 9. X squared, 9 squared is 81. 50 minus 81 is negative. The bottom of the fraction is positive. So this interval here, my derivative is negative. So my critical point, where x is the square root of 50, is a max. Why is it a max? By the first derivative test, a prime switches from positive to negative at the square root of 50. And it's my only critical point. So that's my only critical point in the interval, and it's a local max, so that's my maximum value. Now, let's answer the question. The question was, what is the maximum area? All we found so far is x. We got to come back and figure out what y is. And we notice right here, we had our equation for y. So y is the square root of 100 minus x squared. Oh, look, we had x squared right there. So 100 minus 50. So y is also the square root of 50. So x is the square root of 50. Y is the square root of 50. Let's get that area. We have a triangle. 1/2 the base times the height. Square root of 50 times square root of 50 is 50. Divided by 2 is 25 square units. We've already shown that that truly is the max, so that completes our problem. And it was multiple choice. So let's just double check our choice over here. And that looks to me like choice B, 25, completing our problem.